Good morning, students. In the last class, I started with the decision table based testing. In the last class, I explained what are the decision tables, how they are constructed, and what they consisting of, and I explained the construction of the decision table for the triangle problem. Right. So, as you know that the decision table consisting of four parts: stub part, entry part, and in the stub part we have two parts. One is the condition part and the other one is the action part. Condition part is represented by C and action part is represented by A. Conditions are nothing but the inputs, whereas the actions are nothing but the outputs. Right? And I considered the example of a triangle problem, and we have constructed the decision table, right, that I explained in the last class. Along with that, I also explained the construction of the decision table for the next date function. So in the next date function, we are considering the month, year, and the date, right? That also I explained. So we'll consider the test cases for the triangle problem. So today you're going to study the construction of the test cases for the triangle problem. Next we'll move on to the next date function. We'll see these today's class. Okay. So first I'll start with the construction of test cases for the triangle problem. So yes, you already know that the conditions for the triangle problem, right? So first you have to check whether we can construct the triangle or not, right? So if not possible, then we'll display the message as not a triangle. And if it is possible to construct the triangle, after that we are going to identify what type of a triangle it is based on the sides of a triangle. If all the sides are equal, then we'll represent it as equilateral triangle. If two sides are equal, then we'll represent it as an isosceles triangle, and if no sides are equal, then that we are representing as a scalene triangle, right? These are the three types of triangles that we are considering. Along with that, one more option that we are considering, that is not a triangle. Means if it is not possible to construct the triangle, then we are going to display the message as a not a triangle. So for these cases, we are going to construct the test cases. So to construct the test cases, we are considering the decision table, or by using the decision table of the triangle problem, we are going to construct the test cases. So here, first I'll show you the decision table for the triangle problem. Right. So this is the decision table for the triangle problem that we have considered, right? And one more is there, right? We'll see that. Decision table techniques, it is over. Yes, this is the basic decision table for the triangle problem. So here we are considering the values of ABC. By considering ABC value, can we form the triangle or not? After that, if we form the triangle, then we are considering the ABC value. By considering the ABC value, we are going to identify what type of a triangle it is, right? So here, so first case is not a triangle, and in the second case, if it's possible to construct the triangle, then we are considering the value of ABC. Based on the value of ABC, we are going to identify the triangle as a equilateral triangle, isosceles, or the scalene triangle. So this decision table I explained in the last class. We will use this decision table to construct the test cases that you are going to study now. So this is the construction of the test cases by using the decision table. So here we are going to identify 11 functional test cases by using the previous decision table. Here we are going to construct the 11 functional test cases, and among 11 cases, 3 are the impossible cases. So here this is impossible, impossible, impossible. So 3 are the impossible cases and 3 are the not a triangle cases, and 3 are the isosceles triangle cases, and 1 is the equilateral and 1 is the scalene. So out of 11, 3 are considered for the naughty triangle, and 3 are considered for impossible cases, and 3 are considered for isosceles, and 1 is considered for the equilateral, and the other one is considered for the scalene. So these are the test cases are defined, okay, by using the decision table. So this is the case ID is given dt1, dt2, dt23 indicates that these are the decision table test cases 1, 2, 3, 4, 5 like that. So if you give the value ABC as 4, 1, 2, then it is not possible to construct the test case. Why? Because here we are checking the condition that whether A is less than B plus C. So here A value is 4 and B plus C is 3. So 4 is not less than 3, and hence it is not possible to construct the triangle. So that we are considering. See here in the decision table we have considered that case. See here in the condition C1 we have represented with the A less than B plus C or not. If it is true, means if A is less than B plus C, then only it is possible to construct the triangle. So if A is greater than B plus C, then that is if A is less than B plus C is false, then it is not possible to construct the triangle. So that the test case we are considering. Similarly, we are considering the B value, C value. B should be less than A plus C and C should be less than A plus B. So we are considering these three cases. See here, in the first case, so A is less than P plus C, no, it is false. So A is, in this case, A is greater than B plus C. So that condition is not satisfied, and hence we are not, it is not possible to construct the triangle because the A is less than B plus C condition is failed. Our condition is not satisfied, hence it is not possible to construct the triangle. Similarly, for the second one, dt2, here we are checking, entering the values for ABC as 1, 4, 2, and here we are checking whether B is less than A plus C. No, it is not possible, right? Here it is B value entered as 4 and A plus C is 1 plus 2. 1 plus 2 is 3, where B value is 4. So B is here, it is greater than A plus C, and hence it is not possible to construct the triangle. Similarly, for the third case, we are considering dt3, here A value is equal to 1, B is equal to 2, and C is equal to 4. Here we have to check the condition that whether C is less than A plus B. Is it satisfied? No, because A plus B is 3 and C value is 4. So that condition is not satisfied, and hence it is not possible to construct the triangle. Understood. Next case we are considering the dt4. Here A is equal to 5, B is equal to 5, and C is equal to 5. So first three conditions are satisfied. A is less than B plus C, B is less than A plus C, and C is also less than A plus B. So it is satisfied and it is possible to construct the triangle. So if it is possible to construct the triangle, then we are going to identify what type of triangle it is. So based on the sides value. Here A is equal to 5, B is equal to 5, and C is equal to 5. Means all sides are equal. If all sides are equal, then we say that the triangle is a equilateral triangle. Next, we are considering for the impossible cases. If A is unknown, or B is unknown, or C is unknown, so whatever may be the value, then it is impossible. So this case we are normally considering if A is equal to B. So that here I explained, right? We consider that case itself. So here you check it. So for the impossible cases, what happens when these three conditions are true and A is equal to B and A is equal to C, then if we set B is equal to C as false, then it is impossible. Why? Because in these two conditions, C4 and C5, it is already represented that A is equal to B and A is equal to C. What it indicates? It indicates that A is equal to B, B is equal to C. Then these in the first two conditions, that is C4 and C5, it is true. Then In C6 we are represented it as false, but it is not possible because in these first two condition itself, that is in C4 and C5, all three are equal. Then if we set that B is equal to C as false, then it is impossible to set. That's why it is represented as impossible case. Similarly, the others, second one, this one, this rule is also for the impossible one. See here, a is equal to b is set and b is equal to c is set. Then a is equal to set it as false. It is not possible. Hence, it is treated as the impossible condition. Similarly, for this rule, here what happens? A is equal to b is set as false, but a is equal to c and b is equal to c is set as true value. Then if A is equal to C, B is equal to C, then we cannot set A is equal to B as the false. It is impossible. So for these three cases we are considering here, as the question mark here it is represented. So for these two and this one. This one indicates that these are all the impossible cases. So here these test cases are constructed by using this table itself. So we are using this table along with the first one. So this one, or if you consider directly this one, by considering this the table, or we are using this decision table to construct the test cases for the triangle problem. Okay. So these three natted triangle, three are impossible and three are isosceles. If any two sides are equal, see here, a is equal to b and c is some other value, and here a and c are equal and b is not, and in this case B and C are equal and A is not equal. So in all three cases, two sides are equal and one more is not equal. So for that we are considering it as a isosceles triangle. So this is the expected output. If two sides are equal and one side is not equal, then we say that it is a isosceles triangle. So three cases for that. And next one is for the the last one, the test case DT11 is for the scaling. If A is not equal to B and B is not equal to C, then we say that it is a scalene triangle, means none of the sides are equal. If none of the sides are equal, then we say that it is a what type of triangle? It is a scalene triangle. So by using the decision tables, we have constructed the test cases for the triangle problem. Similarly, we can construct the test cases for the next date function by considering the decision table. Here, this is the decision table for the test cases, right? This is the one. Here we are considering only the months, and here we are considering the month value, whether it is true or false, and what are the impossible cases that you have considered, and this table. So with the help of these decision tables, we are going to construct the test cases for the next date function. So to construct the test cases for the next date function, first we have to identify the appropriate conditions and the actions. So we are defining the three values for the months, four values for the day, and two values for the year. So for the month we have defined, as I said, we have defined three values. One is the month which consisting of 30 days, other one is the month which consisting of 31 days, and one more is the month which is the February. Why we are treating the month February month separately? Because it consisting of 28 or 29 days depending on the type of a year. If it is a leap year, then the February month consisting of 29 days. If it is not the leap year, then it consisting of 28 days. That's why we are treating the February month as the separate one. Clear? Next, after defining the month value, we are defining it for the days. So here four are defined. One is for that month which consisting of 30 days, other one is the days which is equal to 31 days, because some of the months consisting of 30 days, some of the months consisting of 31 days, and the February month consisting of 28 days or 29 days depending on the type of a year. And two values are defined for the year. One is the year which is the leap year, and the second one is the year which is not the leap year. So these conditions we are defining, and we'll use this in construction of the test cases. Okay. So if impossible conditions are highlighted, then could make a limited entry decision table with the following conditions and actions. So here we are using these condition and actions. Uh, that is the decision table will have 256 rules, and among 256 rules, many of the rules are impossible rules. And if you want to show the rules which are impossible, then we can revise the actions, because here A1 is the day invalid for this month. Suppose for the February, if we say it is a 30 days, then it is a impossible. Why? Because the February month consisting of either 28 or 29 days. Understood? So then that we are considering as a impossible case. And next one is cannot happen in a non-leap year. Suppose if we consider it as a 1993, the year is 1993 and it is not a leap year. So if it is not a leap year, then how many days will be there in the February month? In the February month, only 28 days are there. But suppose if we give the input as 29th February 1993, then it is not possible, because that day cannot occur in the non-leap year. So that occurs only in the leap year. So that is an impossible case. And if we give the proper inputs for all the month, day, and year, then the program is going to compute the next date. Okay. And so we are considering these are the actions. Okay. Hmm. Next, first try with the decision table with the 256 rules. So here we are considering the first try and the second try. So in the first try, we are considering the months which are true for only one value. Right. So month, if we consider month M1 as the, wait, what are the values defined for month? So for M1 it is defined as 30 days, and for M2 it is 31 days, and for M3 it is February, right? So here we are considering month in M1. If it is true, means if we enter the day within the 30 days, then it is the true value. And month in M2, which is consisting of 31 days, and month in M3, it is nothing but the February. So only those three, only for that particular entry, it is the true value, and for the remaining, it is not possible cases, or the input cannot occur for that. Okay, so for month M1, we have defined 30 days. If we enter it as 31, then it is an impossible rule, because that particular month which consisting of only 30 days. If we enter 31, then it is not possible. Similarly, for month in M2, it consisting of 31 days. If we enter it as 32 or 33 or greater than 31, then it is impossible. And month in February, month in M3, that M3 is nothing but the February month. If we enter the values within the 23, then it is set it as a true value. Then if it is greater than 29 days, then it is the false, or it is impossible state. Right. So that we are considering. So that is about there. Then we are having five more conditions for the days and year. So day in D1, day in D2. So day in D1, here we are considering, yes, whether the number of days are ranging from 1 to 28. Day in D1. So C for condition, we are defining it as the number of days which are ranging from 1 to 28, and for C5 day in D2, that we are considering as day is equal to 29 for the leap year, and C6 condition day in D3, that we are considering for the months which consisting of 30 days, means D is equal to 30, and day in D4 we are considering the month which consisting of 31 days, then we are assigning the day value is equal to 31, and year in Y1, and that we are considering it as whether it is a leap year or not. So that we are defining here, y1 is a leap year, then we'll define one more condition C9, there it is defining it as the year which is not a leap year, and based on the values of month, day, and year, we are considering the actions are impossible actions, and if we enter the inputs in a proper value, or if we enter the proper input values, then the program is going to compute the next date. So as I said, I have defined this, right? D1, D2, D4, 28 days, 29, 30, 31, and the leap year. So leap year is defined, and the Y2 year, which is not a century leap year, and the second one is the not a leap year or the common year. So if you can give it as a 1993, then it is not a leap year and it is the common year, right? So these are all the values you are considered. So in the first case, in the first try, see here, we are just considering year, whether it is a leap year or not. Only that condition we have considered. But in the second try, we are considering other two extended options for the year. That is century year we are considering, and the other condition is Y2, which is not which is non-century leap year, and the third one is which is not the leap year. So here in the second try, what we have done, the year which is defined in the first try is expanded into two more values, that is even a year which is the leap year and the non-century leap year and the common year. So that is expanded, year is expanded. So to produce the next date of a given date, so we are considering the five possible actions or five possible outputs. One is the incrementing the month, incrementing the day, resetting the month, and incrementing the year. So first case is incrementing the month. Suppose if we give the date as 31st February 1993. Okay, 31st January 1993. It is the valid input we have given, right? Because the January month consisting of 31 days, January, so it is the valid month, and 31 days it is the valid day, and 1993 it is also a valid day. So if we give the valid inputs, then the program is going to compute the next date. So what will be the next date? The next date is, what is the next day? Next date is 32. 32 is not the case because the January month consisting of only 31 days, right? So the next day becomes the 1st of February. Here, what happened? The month is incremented as well as day is incremented. After January 31st, what we are going to get? We are going to get February 1st, right? So hence it is incremented in month and incremented in day. So both cases are possible, right? So incrementing the month and incrementing the day. And the second one is, third case is here, the resetting the day and resetting the month. So once it is given the proper output, then we are resetting according to the outputted value. Next, fifth case is the incrementing the year. Suppose if I enter the date as 31st December 1996. Okay, 31st December 1996, it is the valid date, right? Because December, it is the valid month, and 31 is the valid day because the December consisting of 31 days, and 1996, it is within the given range, right? What is the range given? 1812 to 2012. Within that it comes, right? 1996 lies within the given range. Hence, if I enter the date as 31st December 1996, it is the valid input. Then the program computes the next date. So what will be the next date? Here, the next date becomes the January 1st, 1997. So in this case, what happened? Day is incremented, month is incremented, as well as the year is also incremented. So incrementing the month, incrementing the day, and incrementing the year, all three outputs we are going to get in the next date function. So it will compute the next day. When it computes and display the next day, there the month is incremented by 1 and the day is incremented as well as the year is incremented by 1. So this is the case. So these are the possible actions that we need to know. So we'll see the second iterate decision table with 36 rules. So here month is given M1, 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 M2. So we are defining the set of rules, right? And we are considering the number of days in that and what will be the year. So based on the month, day and year, we are going to get the value. So if it is the uh, so as I said, we are going to define six actions or the six output based on the value of month, day and year. So first one is the impossible, second one is the increment the day, reset the day, or increment month, reset the month, or increment the year. Um, okay. So here we are considering the how many rules are there? Here we are going to consider the 16 rules. One here 1, 2, 3, 4, 5, 6, 7, 8, and the remaining 8 rules are here. 7, 8, 9, 10, 11, 12, 13, 14, 6, 14, 15, 16. So 16 rules are there. Okay, so for these, we are considering these 16 rules in the second try decision table, and based on the month, day, and year, we are going to get the outputs in the form of actions. So the rule 4, what the rule 4 says? Rule 4, it is there. Wait, I'm going to see this. Mm. Or okay, I'll consider directly an example and I'll explain whether it is a for the impossible case. Okay. So the rule 4 here in the rule 4 we have M1, D4 and the expected output is the impossible. So what the M1 says or what is the value we defined for M1? M1 is equal to 30 days. So that is we are defined here. See here. For M1, 30 days is defined. For M2, 31 days is defined. For M3, it is February. Okay. And for D1, it is 28. For D2, it is 29. And D3, it is 30. And D4 is 31. 28, 29, 30, 31 for D1, D2, D3, D4. Okay, we'll consider this. So let us consider for the rule 4. Rule for M1 means it consisting of only how many? 30 days is defined for M1. And if it is D4, what are the values we defined for D4? See here it is 31. So if M1 is 30 that we have defined and D4 is equal to 31, then it is impossible. Let us consider that M1 is the February month. Okay. Sorry. M1 is the April month. So we have defined the month for M1 is April, and D4 it is equal to 31 days. Then what happens? April month 31 days. Is it possible? No, it is the impossible case. Why? Because the April month consisting of only 30 days. And hence, if we set the value M1 as true and D4 as true, then we are getting the output as impossible because the April month is consisting of only 30 days, and if we set it is D4 as 31, then it is the impossible. So we'll get the error message as it is the impossible output. Clear? Next, we'll start with the rule M1 and D1. So M1 is the month which consisting of 30 days, right? So how many months consisting of 30 days? April, June, then September, then November. So these months consisting of 30 days, right? So those months we are considering here D1. D1 is what the D1 value? It is equal to 28, right? Month which is having the 30 days. M1 indicates the month which is having the 30 days and D1 is equal to 28. So if we set this as true, C1 as true and D1 as true, then it is said that the correct month and day is entered, then the day is incremented by 1. Similarly, for the M1, D2 is equal to 29. If both are true, then also the day is incremented. And here, M1 is the month which consisting of 30 days and D3 is equal to 30. So we enter the correct or the valid inputs, then it computes the next value. So what will be the next value? Month is equal to the month which is having 30 days, and D3 is 30. So after computing that, it is resetting the day, because the day is incremented by 1, then it becomes 31, but 31 is not there in April or June, so hence it is resetting to the new month and new day. So resetting the day and incrementing the month, because after April we are going to get the month May, and hence we are resetting the day to 1, and the month value is incremented and the month becomes May, like that. And next one is M1 and D4. As I said, the months which consisting of 30 days, if we set the D value or the day value as 31, it is the impossible case. Next we'll move on to the second case M2, where M2 is nothing but the month which consisting of 31 days, and D1, it is equal to 28. If we set M2 and D1 as true, then it indicates that we have given the valid inputs. If valid input is given, then the day is incremented by 1, because if we give D1 as 28, and after that the next day is computed, it becomes 29, as the day is incremented by 1. Similarly for D2, D2 is equal to 29 days, and M2 is the month which consisting of 31 days, right? So then it becomes the day is incremented after 29, we are going to get 30th. And D3, what is the D3 value? D3 value we have setting it as 30 days. D3, if both are true, then indicates that it is the valid input, then the day is incremented, then that becomes 31. Next one is the M2 with D4, the month which consisting of 31 days. So if you consider the example of a January or March, so that month consisting of 31 days, and D4 is set to 31. So if we give the valid input as January 31st, and if this input is given, the program is going to compute the next day. So what will be the next day? The next day is reset to 1, then that becomes, if you give it as January 31st 1996, then it is giving the value as February 1st 1996. So the day is resetted and the month is incremented, okay, depending on whether it is the month which is between the January to November. So suppose if I enter it as a December 31st, then what happens there? December 31st, their day is incremented, month is incremented, and also year is incremented. So that's why these three are put it in the question mark, means depending on the value of M2 and D4 value. If it is the December 31st, then what happens? We have to increment the month, we are resetting the month to January, and we are incrementing the year. So that is given for this, okay. And next, these are the 8 rules, and the remaining 8 rules for M3. So for M3, what are the values? M3 is defined here. M3 is the February month, okay. For February month, and here is also given, right? Y1 is given, Y1 is 2000, right? And if that is the case, see here, if M3 and D1, if 28 days are there, then we are incrementing the day, and M3 D1 2000, it is incrementing the day, and M3 D1 and Y3, sorry, here it is Y2, right? Y1, Y2 and the Y3. So what is Y3 value? Here Y3, which is the year, it is a common year, means it is not a leap year, okay. So Y1 indicates it is 2000, and next one is the non-century leap year, and Y3 is the common year. Common year means it is not the leap year. So these three conditions we are considering: Y1, Y2, Y3. Y1 is 2000, Y2 is the non-century leap year. So if it is 1996, it is a non-century leap year, right? And Y3, if you consider it as a 1993, then it is the common year or not a leap year. Then based on this, yes, year, if Y1 case it is the leap year, then the day is incremented by 1, and Y2 is also a non-century leap year, then the day is incremented by 1. Why? Because D1 is set as 28 here, and if it is the valid input, then it computes the next day, then the next day becomes February 29th, hence it is represented as incremented by 1, incrementing a day. Next, M3, D1 and Y3. So depending on the type of a year, if it is Y3 indicates if it is not a leap year, then what happens? Then the month is incremented and year is incremented, but day is reset. Okay, so that's why put it in the format of question mark. Why? Because these two conditions based on the type of a year. If it is not a leap year, okay, then we are resetting the day and the month is incremented, and if it is the leap year, then the day is incremented. For that purpose it is represented in the form of a question mark. Okay, next we'll move on to the M3 with D2. M3 D2 means M3, if you consider it as a February month, and D2 is 29 days. If it is a leap year, then we are resetting the day 29. After that it becomes 30, but 30 is not there in the February, hence we are resetting the day to 1, and the month is incremented from February to March. Similarly, for the non-century leap year, here we are resetting the day value as first of March. So incrementing the February to March, and the day is resetting from 29th to March 1st. Hence these are represented with X. Okay, this is the expected output. Okay, and similarly we'll consider for the remaining three condition M3, D2, Y3. So if it is not a leap year, then 29 days is not possible. So hence it is represented with impossible dates. And M3 with the D3, D3 is 30 days. It is not at all possible in the February month. And M3 is D4, that is 31 days. 30 days and 31 days are not possible. Whatever may be the year is, but 30 days and 31 days are not possible in the February month, and hence the actions or the expected output is represented as the impossible outputs. Okay, understood? Any doubt in this? Suraj, Sharanya, Gaurav?
No, ma'am.
Okay. Next, we'll
Yes,
move
ma'am.
on to the test cases for the commission problem. Uh, you already know what the commission problem is. In the commission problem, the sales person is expected to sell the stocks, locks, and the barrels. Right? Depending on the sales, he is going to get the commission. So if he sell the stocks, barrels, or the locks up to $1,000, he is eligible for 10% of the commission, and from $1,000 to $1,800 he is eligible for 15% of the commission, and if he sells more than $2,000, then he is eligible for the more than 1,000. If he sells the stocks, locks, or the barrels more than $1,800, then he is eligible for 20% of the commission. Understood? That is the commission problem. Here we are going to write the test cases for the commission problem with the help of the decision table. The commission problem is not well served by a decision table analysis, because here we cannot represent it with the true or false condition, but because the very few decisional logic is used in the problem, because they have clearly specified what is the sales he has to do and what will be the commission he is going to get. That is clearly defined, right? Those, and but here very few decisional logic is used, and hence the because of the variables in the equivalence classes are truly independent, and no impossible rules will occur in a decision table in which the conditions are corresponding to the equivalence classes. But if we consider the triangle problem or the next date problem, they number of impossible rules or impossible cases occurs, but in the commission problem it is not. Why? Because in the commission problem the condition is clearly defined, right? They are given how many barrels or how many stocks or how many logs he has to sell and what is the commission he is going to get. That is clearly defined in the problem itself, and hence no impossible cases occurs. So here, hence in the commission problem, in the decision table, we can use the same equivalence test classes that we have studied in the previous chapter. We can use the same set of testing cases in the decision table cases also. So this is about the construction of the test cases by using the decision tables for the triangle problem and the next date function problem we have studied, but the construction of the test cases using the decision tables for the commission problem is not possible. Why? Because the here the commission problem is not well served and very few decisional logic is used in the problem, and hence no impossible cases occurs, and hence we can use the same equivalence test classes as the decision table test cases. Okay, we can use the same thing and we can test the commission problem. So this is about the decision table test cases, construction of the decision table test cases by using the decision tables. Next, we'll see what are the guidelines and observations in the decision table based testing technique. Okay, so decision table technique is indicated for applications characterized by the prominent if then else logic or logical relationship among the input variables or calculations involving the subset of the input variables. Means here we can use the decision table technique to construct the test cases if the problem is characterized by the if then else logic or the logical relationships among the input variables, and if it involves the calculations involving the subsets of the input variables. Okay, and the decision tables cannot be scaled up very well because it is having a very limited entry table with the condition which is having 2 power n rules. And the third one is, as with other techniques, iteration helps. The first set of conditions and actions are identified, which may be the unsatisfactory. Means the set of conditions or the actions identified may be not satisfied, and it is use it as the stepping stone for improving on it until satisfied with the decision table. Means this one we can, because in the iteration case we can use it as a stepping stone until we will satisfy with the decision table. Okay, so this is about the guidelines and observations for the decision table based technique, and this completes the chapter. Okay, so in this chapter, what are the things you have studied? What are the things you have studied? You have studied what are the decision tables, how the decision tables can be constructed, and how we can use the decision table for the construction of the test cases for the triangular problem and the next date function problem. Okay, understood? Any doubt? You can give the attendance. Any doubt? Sharanya, Gaurav, and Suraj?
No, ma'am.
Okay. Then in the next class, I'm going to start the new module. Means I'm going to start the third module in the next class, because so 4 chapters I've already completed from the second module, right? So what are the chapters I completed in the second module?